In question 2, we are looking at discrete random variables and have been provided with this probability distribution here. And in part A, we're asked to write down an equation in P and Q. So if we look at this row here, this represents probabilities. So we know that if we sum all these together, so that's P plus P, which is 2P plus Q plus 0.2 plus 3, which is 0.5, that must equal 1. So we can therefore just rearrange this and say that 2p plus q is going to equal 0.5. In part B, we're told that the expected value from this probability distribution is equal to 0.4, and we're asked to use this to find the value of q. So the expected value, remember, that's just going to be negative 2 times p, which is negative 2p, plus negative 1 times q, which is going to be negative q, plus a half times 0.2, plus 3 over 2 times 0.3, which is going to be 0.45, plus 2p. We know that's going to be equal to 0.4, and we can see that this is going to cancel out with this. So I can just rearrange this to get an answer of q is equal to 0.15. We're told in part C to hence find the value of p, so somehow that means we're going to have to use this value of q here. Well, it should be fairly straightforward. We've got an equation in terms of p and q, so essentially all we're going to do is substitute this value in for q and solve for, so we're going to have 2p is equal to 0.5 minus q, and we said that that is 0.15. So we're going to end up with 2p is equal to 0.35, and therefore p is equal to 0.175. In part D, we're looking at variance. We are told that e of x squared is equal to 2.275. So we need to be familiar with this formula. Here the variance of x is equal to e of x squared minus e of x all squared. And this should resonate with the formula for variance when you are looking at bivariate data, where you're looking at the mean of the squares minus the square of the means, which is essentially what we've got here. So we're just going to substitute in there. We've got from the question e of x squared, which is 2.275, and in the previous question we've got that e of x is 0.4, so if we substitute that on, we will get an answer of 2.115 for the variance. In part E, we're told that this probability distribution function forms the basis of a game between Sarah and Rebecca, and we're told that Sarah's score effectively mirrors the score that we've got at the top here, whereas Rebecca's is the inverse of each outcome here. So the first thing we're going to do is write in Rebecca's score, which is going to be negative at a half, negative 1, 2, 2/3, and half. We're asked to find the expected value of r, so all we're going to do here is exactly what we did in the previous example. We're going to take the probability that this outcome occurs and multiply it by the outcome itself. So we're going to do 0.175 multiplied by a half and add 0.35 multiplied by negative 1, 0.2 times 2, 0.3 times 2/3, and 0.175 times a half. And if we do all that, adding those together, we end up with an expected value for r of 0.45. In part F, we are told that the winner is the person with the highest score, and if the scores are the same, the game is a draw. And we're then asked to find the probability that Sarah is the winner and Rebecca is the winner. So the first thing to do here is to identify who is the winner in each instance. So if we look at the first instance, well, Rebecca has got the highest score. In the second outcome here, we can see that they've both got the same score, in which case it's a draw, so we're not interested in that. In the third instance, it's Rebecca who's going to win. In the fourth, it's going to be Sarah. And in the fifth, it's also going to be Sarah. So the probability that Sarah is the winner, well, it's going to be 0.3 plus 0.175, which is going to give you 0.475. And similarly, the probability that Rebecca is the winner, well, she's going to win in the first and the third outcome. So you're just going to add together 0.175 and 0.2, and that gives you an answer of 0.375.